Hello, beautiful people, and welcome to 11.4. Our SWABAT is to add and subtract rational expressions. From your warm-up, if you've completed it, you should check your answers with mine. You should have had 1 over 15 for number 1, and then for number 2, 5 over 9. For this lesson, we're going to be learning how to add and subtract rational expressions. So what you saw from your warm-up is that you have to have like denominators in order for you to be able to add these. So easing into it, for number 1, one thing that you notice is that they both have the same denominator, n squared minus 9 and n squared minus 9. So for me, I'm going to go ahead and combine like terms up top. So because the denominators were the same, I'm going to go ahead and write that n squared minus 9. And then for your numerator, it's going to be 2n plus 3, and then this is a minus sign, so minus n. Then, combining like terms, I have 2n minus n is just n plus 3 over n squared minus 9. Now, similar to what you did in 11.1, I'm going to have you factor the denominator to make sure that we can't reduce this any further. So I have n plus 3 up top. In your denominator, this is a special product, and if you remember it, it's a squared minus b squared is equal to a plus b times a minus b. So for this case, this is like n squared minus 3 squared. So this will be n plus 3 times n minus 3, using your favorite special product. Now, looking at these, I see that they both have an n plus 3 in common, so I can reduce that. And I have n minus 3 left over in the denominator, but up top, I just have a 1. And that is your final answer. Looking at letter B, they again have the same denominator already, which is nice and user-friendly, so I'm going to keep that at m plus 4. And then I'm just going to combine the numerators, 5 plus 7. So I get 12 over m plus 4. And because this is already in factored form, there's nothing left for me to do. So for your next example, we would like to find the LCD, find the least common denominator of both of the rational expressions. So we're not going to add these, we're not going to subtract them. All we're looking for is what is the LCD. It's a skill you're also going to need for 11.5, so make sure you're with me on this. So we're disregarding the numerators because no one cares, and you're looking at 28 and 7. What's the number that they can both go into, the smallest number that they can both go into? So for 28 and 7, I would say that my LCD would be 28. And then I'm looking at k squared and k cubed. K squared and k cubed. So k squared is k times k, period. And then this is k times k times k. And then already in common they have 2, but this one has 3. In order for them to be exactly the same, I'm going to need this to be k cubed for that one. K cubed is the smallest one that they could both fit into. Your shortcut for that is you're pretty much always going to go with your highest exponent. Looking at B, oh, that's it for that. So you can go ahead and box it if you'd like. Looking at B again, you're disregarding the numerators for now. And in the denominators, they don't really have anything in common. You have an x plus 5 here, and then you have a 9 there. There's nothing in common. So in order for them to be exactly the same, I'm going to have one of them be an x plus 5, and then I'm also going to have a 9. So that's as much as you can do for your LCD. That is similar to when you had like 1/2 plus 1/3. They don't have anything in common. So in order to get 6, you're basically multiplying the two other denominators together. So you get 6 and then 6. This is how we come up with our LCD if they don't have anything in common whatsoever. You just write them side by side. Okay, let's try to put that into practice. Example 3 asks us to find the sum or difference again. Similar to what you did for number 1, except now you're going to have to get the LCD. So you're combining what you did with number 1 with number 2 in order to work out this next example. So I'm looking at these and they don't have the same denominator. So I'm going to have to find that first. Now this is a 1 and this is a 7. What would your LCD be if you just had a 1 and 7? Well, it'd be 7 because they can both, the smallest number they can both go into is 7. Then you have your n's. You have n cubed and n squared. N cubed and n squared. And they could both fit into n cubed. Only thing is, you can't just change the denominator and then think that it's okay. There are some steps. So for this one, you started off with n cubed, but then you became 7n cubed. What did you do? Well, you had to multiply the denominator by 7. Now, whatever you do to the denominator, you also need to do to the numerator. So now you're going to have to multiply 7 times 27. So using a calculator, I have 189. And then for this one, what's the difference between the 7n squared and 7n cubed? Well, the 7's were the same, but I went from n squared to n cubed. How did we do that? Well, I would need to multiply by another n here, because n squared times n is n cubed. And whatever I do to the denominator, I'm also going to do to the numerator. So negative 9 times n, 9n. I'm not going to make that negative sign there, though. So now that you have your common denominator, you can go ahead now and combine like terms. So I have 189 minus 9n over 7n cubed. Then you ask yourself the question, can you factor this at all? Is there a number that goes into 189 and 9? I'm thinking 9 does, actually. So if I factor out a 9 here, it's like dividing by 9 and dividing by 9. Left over, I would have 21 minus n over 7n cubed. Looks a little bit funky, but it's correct. Okay, example B. Find the sum or the difference. Again, you still need to find your common denominator. And I'm looking at these two fractions, and this is g plus 2 and g plus 1. They don't really have anything in common because these would have to be multiplying in order for them to have that g, or in order for me to claim that g. So I'm going to write them side by side, g plus 2, g plus 1, and g plus 2, and g plus 1. Can't do that without making some changes up here. So this already had the g plus 2. That was great. But I added this g plus 1 on there. So whatever I do to the denominator, I'm still going to do to the numerator as well. Now let's multiply. 1 times g is g, and then 1 times 1 plus 1. You're distributing 1 and then 1. And then this one was g plus 1 originally, and we changed it to g plus 2. So I'm going to multiply by g plus 2, multiply by g plus 2, and okay, my apologies. 3 times g, that's how I got my 3g, and then 3 times 2 is 6. Now you're going to combine like terms. So your denominator was great. It's still g plus 2 times g plus 1. And then up top, you're going to add them because it's got a plus sign. So g plus 1 plus 3g plus 6. Now combining your like terms, you have g and 3g, so you have 4g. Plus, then you have 1 and 6. When you combine those, you get your 7, all over g plus 2 times g plus 1. And there you are. And finally, let's try this last one. Now, if you are feeling up to it, you can go ahead and press pause and try it on your own, and then fast forward through my explanation. But if not, stay with me. Looking at these two, there's nothing they have in common. So I'm going to go for x minus 5 times x plus 4. And I'm going to do it again. X minus 5 times x plus 4. Now you're multiplying the numerator and denominator by x plus 4 and x plus 4. Now I'm going to distribute. 2x times x is 2x squared. And then 2x times 4 is 8x. For your second one, hopefully you multiplied by x minus 5 on the top and bottom. And so my new numerator is 9x minus 45. Combining like terms, what do we get? Well, I'm going to have 2x squared plus 8x, that's your first fraction, plus 9x minus 45, all over x minus 5 times x plus 4. Okay, let's simplify. 2x squared plus 17x minus 45 up top, because you're combining your 8x and your 9x. And then in your denominator, you have x minus 5 times x plus 4. Then you would check to make sure and see if you can factor this. So in order to factor it, you would set up your factor box, and you have your 2x squared and negative 45. And you're trying to see, are there two numbers that will multiply to give you negative 90x squared and add to give you 17x. And then after a lot of thought, there are not two numbers that satisfy that, so there's nothing for me to factor for this problem. So that's going to be my final answer. One challenge problem for you is here. It's not on your worksheet, but if you would like to try to earn some extra credit, go ahead and try this problem. I'll give you one hint, and that is to factor first before you find your LCD. Factor first. Then show it to your teacher before the end of the day. Thank you much.